Hi everyone. In this video we're going to look at a method called U substitution for finding indefinite integrals. And you can think of this as finding the antiderivative of chain rule. Okay, so it's like working backwards from chain rule. Now here is your rule, okay, written in red, which I know at first is a little confusing. So I tried to give you some steps to make it a little bit easier. But basically, you're going to have an inside function and an outside function, okay? So you want to start by setting u equal to the inside function. Then you want to find the derivative of u, which would be du over dx. Then you're going to substitute with u and du, okay? And basically, at that point, you're going to end up with an integral that instead of having x as a variable, is now going to have u as its variable, okay? Then you're going to integrate or find the antiderivative in terms of u, and then you're going to replace u with the inside function. So basically, going back to step one, whatever you set u equal to, you're just going to replace u with that function, okay? All right, let me show you an example. It'll probably make a little bit more sense. So here we've got the integral of 2x times x squared plus 9 to the 5th power. Again, look for your inside function, okay? Here, the inside function is the x squared plus 9 because it's being raised to the 5th power, or simply it's inside the parentheses, okay? All right, so step one, you're going to set u equal to the inside function, and then you're going to find the derivative of that. So that's du over dx equals derivative of x squared is 2x, derivative of 9 is 0. Okay, now, usually what we do at that point is you're going to multiply by dx, and you're going to write this as du equals 2x times dx. Okay, now, if you look back to our integral, notice we have a 2x dx, okay? We have 2x here, and we have a dx here, okay? All right, so that basically is the derivative of the inside function, okay? So that's going to get replaced with du. Okay, we're actually ready to do our substituting in terms of u. So our integral is going to become, this is going to equal the integral of u to the 5th power. Now that comes from the fact that x squared plus 9 is equal to u. Okay, so that part just becomes u to the 5th power. And then the 2x dx gets replaced with du because they are equal to each other. So usually when you're replacing with u and du, it's going to get a lot simpler. Okay, like notice this just became the integral of u to the 5th du. Okay, so now you're going to integrate. Here we can just use our power rule. So this is going to equal u to the 6th power divided by 6. Don't forget your plus c. And then your last step is we're going to replace u with what we had set it equal to in the beginning. So this will become x squared plus 9 to the 6th power divided by 6 plus c. Or instead of dividing by 6, you can just multiply by 1/6. And we have our answer. Now, I just want to show you that this does work. Remember, you can always check yourself by finding the derivative. And it it should get us back to the beginning. Okay, so to find this derivative, I'd have to use chain rule. So I would bring my 6 down in front, multiply it by 1/6. 6 times 1/6 is 1. So this will become x squared plus 9 to the 5th power, because we're subtracting 1 from the 6, times the derivative of the inside. So times 2x. And then, of course, the derivative of our constant is 0. And then we could flip this around. And I just want to show you that in fact, got us back to the beginning. Okay? Because that might help you understand that it's basically chain rule backwards. Okay? And by setting u equal to the inside function and then finding the derivative of it, you're really just trying to figure out the derivative of the inside. Okay? All right, let's look at one more example because there's one additional thing that can happen. So here, our inside function would be x cubed plus 1 because it's under the radical or inside. All right, so we're going to say u equal to x cubed plus 1. We're going to find the derivative. So that's 3x squared dx. And you'll get used to just putting the dx behind your derivative. Okay, now we're going to do some substituting. So the x cubed plus 1 is going to get replaced with u. Okay, so we know that eventually we're going to have square root of u. Okay, now I notice that this x squared and this dx is part of my derivative, okay? But we're missing a 3, okay? So here's how I like to think of it. I can add the 3 up here to the original integral as long as I cancel it. So if I multiply by 1/3 in front, 1/3 times 3 is just 1, and multiplying by 1 isn't going to change anything, okay? But now I have everything I need to do my substituting. So the 3x squared and the dx get replaced with du. So now this becomes this integral, which is now in terms of u. But we have to keep that 1/3 in front, okay? Now, it's just a constant multiple, so we're just going to bring it down when we antiderive this. Although, I would convert that radical to a fractional exponent. And then that way you can just apply your power rule. So this will become u to the, we add 1, we get 3/2, divided by 3/2, which remember is the same as multiplying by 2/3, plus c, multiply straight across, and we get 2/9 times u to the 3/2 plus c. And then the last thing we're going to do is replace u with the x cubed plus 1. So we get 2/9 times x cubed. Oh, what's happening? The board stopped working. All right, we're back up and running. So we're going to replace u with x cubed plus 1 to the 3/2 power plus c. And voila, we have it. Okay. So I just wanted to show you in this example that sometimes things don't match up exactly the way you need them to. So you just have to do a little manipulation to get everything to match up. All right, so we will practice this some more in class, and we'll probably look at a few more scenarios, like with your trig functions and exponential and logarithmic functions. All right, I'll see you then. Have a good night.